Hyderabad, roughly around 50 kilometers, there the Acharam site is there. There is a magnetic dike across the hill. On that we flow and we took the data and published concepts. I will show you the next concepts paper. This lab, I was really surprised to see these applications are existing and there are a lot of scope to have development in this area. So coming to this presentation, even though the workshop related to wireless sensor networks, I am just tuned my presentation and the what work NGRI does. The both I am trying to fine tune and put in front of you some geophysical applications and challenges where anyone can have some interest to take up this kind of area. Now, first I will talk regarding geophysical applications, then I will give you what are the geophysical applications you can target using wireless sensor networks. So coming to the introduction, so basically geophysical applications involve study of physical properties. Now coming to what is this physical properties? Like our human body, we go for the blood test. They do all CBP, all kind of tests. We will be knowing what is there in our body. Like Earth also have some physical properties where we need to apply some methods, some tests, so that we can have the physical properties of the Earth. So those kind of methods we will be applying. Like for example, Earth will have magnetic field. So even surrounding this room also we have a magnetic field. So that can be measured by even, I don't know how many of you know, there is an app available in your mobile also. You can measure the magnetic field right now in the spot of this area. So like that, Earth is having many physical properties. So those properties will be, from NGRI side we have many methods which we will be using to measure the properties of the Earth system. Now when you are trying to acquire the physical properties of the Earth system, there are many other technologies also required. In that, one of the technologies that wireless sensor networks, where you need to collect a lot of data which needs to be analyzed. So one of the method is that wireless sensor networks is tremendously using nowadays to pick up the data and to forecast the natural calamities. So the presentation explores various geophysical applications using wireless sensor networks. Now before going to the what are the different kinds of geophysical applications using wireless sensor networks, I will take a real-time development example and the challenge and one activity which we are doing in national wide across the country and trying to contribute to the nation by exploring the mineral around our country. So what is that application? Now I am going to give you first that application. Then after that different geophysical applications I will give you. The method what I am talking is that airborne geophysics history. What is airborne geophysics? See, usually right now there are minerals which is available under the earth. There are many minerals starting from the groundwater onwards, uranium exploration. There are many minerals are available. So how we will explore that minerals from there? So one method is the electromagnetic induction method. Like your EM theory, there is electromagnetic principle. Based on the principle, we apply some source of current to the electromagnetic coil. So that will penetrate to the ground. So we get the electromagnetic data. Where there is some mineral composition, so there will be anomaly. By studying that anomaly, we will be getting the what kind of material is available under there. Say for example, based on the depth of investigation towards the inside the earth, the application will be depends. Suppose near surface, so for example you take you are making borewell, you are trying to pick up the water from the ground. So how much distance? The maximum depth of maybe below 50 meters or 100 meters of under the ground. So when you talk about uranium exploration, you need uranium is one of the mineral. So how much depth you need to go? You need to go at least 300 to 400 meters. So depending on your depth of penetration and source of what is the strength of the amplitude you are able to send to the ground, you will be able to decide the kind of mineral or what are the properties you will explore from the earth. So this airborne geophysics method is one of the methods where we use EM principle to explore the minerals from the earth. Now we started actually this method roughly around I think 1960 to still we are doing this. In this actually the EM system, what the system we are using, which was imported from the Canada. So I will show how the system looks like coming slides. So till now we have covered the almost 1,90,000 line kilometers. So how it will be like 1 lakh? See, the helicopter will be carrying this system like this. The helicopter will be flying. The system will be towed with the ropes like this coil system. So helicopter will be flying across the line kilometers. So if you take a roster scanning like this line kilometers we covered 1,90,000 line kilometers across the nation. In the now, if you see the technical part of this, you need to carry such a big transmitter loop which had a peak dipole moment of 4,25,000 of NIF. We have so much dipole moment is there for the transmitter loop and the weight is 400 kg. The important parameter is that peak current. See the peak current, the value which is 200 amps. See, even in your labs also you use maximum 5 amps, maximum 15 amps. So 200 amps current you need to generate it. From where you will generate it? So the importance is that when you generate 200 amps current and create a dipole moment of 4,25,000, then only the signal will be going inside the earth roughly around 300 to 400 meters. Then only you will be able to get the anomalies which is under the earth. So for example, uranium exploration, definitely you need to go deeper to the earth to get that mineral. because near surface you get only water and very minimum kind of minerals will be available. But when you go deeper only, we get this kind of minerals. Now how it looks in the field. See, when a helicopter stands, I think this much big room will be helicopter size. When helicopter stands there, how the loop size you can see. Imagine the loop size. It's very big, 26 meter diameter. So when it flies to the air, it looks like this from the ground. In field survey, it will be like this. Now coming to the what we have done as a Make in India part, Make in India installation. How now the challenge came to us. Now what last few years we are targeting to design ground electronics like data equity system and transmitter current source and development of this transmitter and receiver working coil configuration. Now what we did, that entire onboard electronics we developed ingeniously at NGRI, and the entire loop system which is hanging to the drone, that whole assembly is designed in NGRI. And drone we have sister lab, National Aerospace Laboratory. They have taken the challenge of developing the drone. So by integrating drone and the system, we were trying to carry out the electromagnetic service. Now, is it the traditional system which will weigh around 400 kg weight? Whether drone is available to pick that 400 kg payload? Is it available? Anyone have any idea about that? No, it's not available. Even abroad also it's not available. It is application specific and very rare requirement for the application. Now we thought of giving to the NAL Bangalore, National Aerospace Laboratory, to build this drone, and unfortunately they couldn't able to do it. We thought of procuring, but even Norway people they couldn't able to supply it. So what we have done? We have started the project. We want to prove that concept. Now, what is the big dipole moment? 4,25,000 we have, which traditional system may have. Now, what we did? The entire this 400 kg system we scaled down to the 100 kg. The principle is same, applications are same, but near surface applications we are targeting.